You have received the task to actually perform an Ingenhousz experiment at your home based on the video that I have previously made, the Ingenhousz experiments. Right, so after you perform the experiment, you will have to deal with a so-called data processing, because the data that you put into the table cannot be used as is. And in this video, in this occasion, I will teach you how to do that processing. Let's say I perform an Ingenhousz experiment to measure the effect of light intensity towards the photosynthesis rate during the day. And I want to prove that the theory I have learned were correct. Therefore, I made 3 setups. Setup A, which is placed in a place without any direct access to sunlight, and the lamp is turned off. Setup B, which is placed in a place without any direct access to sunlight, and the lamp is turned on. And the third setup is placed in a place with a direct access to the sunlight. I observed each of these setups for 5 minutes and I recorded my observation in the following table. Now the symbol that is used to fill the table can be interpreted by looking at the following description. Since I want to prove the theory that states if the light intensity is increased, the rate of photosynthesis rate will be increased up to a certain point until there is no longer any effect, I will have to make a graph that can show the relationship between photosynthesis rate and the light intensity from the data that I have. But before I can visualize my table in form of graph, I will have to change the symbols into numbers. From the theory, we know that if photosynthesis rate is high, then the amount of produced oxygen will also be high and vice versa. With these assumptions going on, I will change the symbol using this conversion table. Since we have not learned about the actual unit of the photosynthesis reaction, we will just use the unit arbitrary for now. Mind you, this unit is used to simplify the analytical process in this occasion. In the real world, however, it doesn't work like that. After replacing the 0 and the plus with an actual number in the conversion table, I will now have the following table. Now I can visualize the table in form of a graph, and I can do so by putting it to the Excel so I can get the following graph. While this graph is actually pretty straightforward, it doesn't contain the right message. What this graph is saying is that photosynthesis rate for each setup for every minute is at a certain arbitrary unit. Setup A, which is located in a place without direct access to the sunlight and also no lamp, has the lowest rate, while setup C, which is located in a place with direct access to the sunlight, has the highest photosynthesis rate. However, this does not answer my question or my goal to prove that if the light intensity is increased, the rate of photosynthesis will be increased up to a certain point until there is no longer any increase. Pay attention here. In order to respond or answer this question, we do not need to talk about the photosynthesis rate per minute. Instead, we have to talk about the average of the photosynthesis rate for each setup. Therefore, we will be taking the average of the photosynthesis rate for each setup and record it in a new table just like this. When we say that we have 3 setups, it would be better if we change the name to something that is more meaningful instead of saying A, B, and C. Therefore, I will replace it with something like this. And by doing this, I will be able to get the information faster and in a more efficient manner. I will now substitute those ABCs in my working table with these labels. Also, we do not need to take the total rate, so we can just erase that column. And this is the table after I process it. I can now visualize this information using Excel. This is the graph that I get out of it. This graph looks good. However, this graph still does not respond or answer our question. The message you can get from this graph is the photosynthesis rate in the condition without light, no sunlight, no lamp, is the lowest, while the highest is when the setup is exposed to sunlight directly. While once again, our goal is to prove that if the light intensity is increased, the rate of photosynthesis will be increased up to a certain point until there is no longer any effect. Here's a note for you. Bar graph like that is appropriate if you want to compare something, but not to prove relationship between two things. If you want to prove a relationship between two things, or if you want to show a progress, if you want to track progress of something, you have to use line graph. However, in order to use line graph, we would have to have values, numerical values for both axes, which is missing in our table. Therefore, we will have to do one final processing, which is converting the condition to numerical value. Here's the idea. Light intensity can be denoted with actual numerical value because it is measurable. The following table have all my assumptions and numerical value assigned to it. I suggest you click pause so you can read all the assumptions and the numerical value. Note that I did not teach you the unit of light intensity, therefore we use the arbitrary unit for the light intensity as well. Now we just have to put the numerical value into our working table like this. Now let's try to visualize our table in a graph. This graph over here has this message. When the light intensity is increased, the rate of photosynthesis rate will also be increased. Whilst I was trying to prove that if the light intensity is increased, the rate of photosynthesis rate will be increased up to a certain point until there is no longer any effect. In this case, there is nothing else I could do because the data have been completely processed to make it possible for us to see the relationship between photosynthesis rate and the light intensity. The last part of my goal, which states that blah 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 up to a certain point until there is no longer any effect, requires me to show that there is a horizontal line on my graph which does not exist. Hence, I couldn't prove the last part because I simply do not have enough data. Because of this, I will suggest to myself to add some more data point from the experiments. For example, by using a lamp with a different light intensity and eliminating direct access to the sunlight condition. This will allow me to actually control the light intensity a lot better since I can control the power of the lamp. And you know, the unit of the power of the lamp is watt. Alright, so now I will teach you how to actually make the graph that I've shown you. Over here, first what you need to do is you need to input all the data into an Excel like this, and after you finish inputting the data, select all of them and you click on the ribbon, click insert, and then click charts. For this one, we will be using the scatter one with smooth lines and marker. So click on it and a chart will be generated for you. Now it has already the chart title, however it's still missing the label of the axis, so we need to add that, and to do that we can click this plus sign over here, chart elements, and then you take the axis title. Now you can change the chart title to match the one that you want. Photosynthesis rate per minute for each setup. And then for the axis title, the x-axis, it should be time, so I will change it into time, and then the unit inside the brackets, minutes. As for the y-axis, we want it to be the photosynthesis rate, arbitrary unit. Now we have already put the title and also the axis title, and the next step is for you to remove all the grid lines in the middle of the chart, because we do not need it, as there will just they will just be a distraction. And then click this, and now you get a clean chart. However, it's not done yet, because usually for a chart we want it to start with a 0, not with a minus 0.5 for the y-axis. And in order to change it, you can click on the y-axis values and then right click on it, format axis. And then over here on the axis options, on the bounds, you see the minimum is 0.5, change it to 0, and the maximum, make it 4. With a major unit of 1, so change this one into 1. And now you get the same graph as the one shown on the left side. For the second graph, which is the effect of light intensity to the photosynthesis rate, you also need to type all the data that you need into an Excel like this. And after you do that, select the data, again click insert, and then for the chart, because this one is more like a comparing between the three, then you should be using a column chart. So pick the one that fits your need. For me, I will pick the first one. Now it has already the title, the x-axis, it has already all the information that it needs. However, it's not clear what is on the y-axis, so you need to add an axis label or axis title. So add it. Because we do not need to do anything else with the x-axis, you can click on the axis title and then delete it, and then change the axis title for the y-axis into photosynthesis rate, the arbitrary unit. And the title is also need to be changed, therefore click on it and change it into the effect of light intensity to photosynthesis rate. Now this doesn't look good, because you see it's pretty long for the top one, but it's pretty short for the second line of the title. So you can just click on at one position and then click enter. Again, after that you will have this graph, but you do not need this grid line. So click on the grid line and then click delete. Now this is how you make the graph, the column graph for this data. And the last graph that I would like to show you is the effect of the light intensity to photosynthesis rate, but this time in a line chart. So again, you need to put all the informations into an Excel and then select it. Pick insert on the ribbon, and then again charts, scatter, and then scatter with a smooth lines and marker. After you do that, make sure you give each axis its own title. Click on the axis titles and start renaming the axis title. So photosynthesis rate, arbitrary. Well, for the x-axis, it should be the light intensity, arbitrary unit. The title is not correct, so I need to change it to the effect of light intensity to photosynthesis rate. Again, it doesn't look good, so I will just click over here and click enter. Now we do not need the grid lines, so once again click on the grid lines, click delete. The same for the horizontal one, delete it. And then for the photosynthesis rate over here, you can keep it as is, because actually the value is like in a decimal format, 0.2, 1.2, 2.2, so you need the decimals. But for the light intensity, over here you have 1, 2, 3, so the whole number. What you can do, you change it to match the one that you need. So over here, because it's a whole number, then I would like for my x-axis to be in a whole number. So you click on the x-axis value, right click, choose format axis. The minimum is 0, set the maximum into 4, and then set the major into 1. And here you have the right graph. And that's it. That's how you make the graph for the photosynthesis, the Ingenhousz experiment. You could do the same for the temperature and the carbon dioxide concentration. Alright, that is all for the data processing for the Ingenhousz experiments. If you still have any questions regarding how to convert the information that you have in the table in your document into a working table that you can visualize using graph like this, you could always reach me through the Microsoft Teams chat. So yeah, I wish you good luck with your report and see you in the next video.